Alright, so let's start. So today I'm going to be talking about HTTP caching in web applications. I'm trying to get you interested in this topic. But before I do that, quick introduction of myself. So I've worked in IT since around year 2002. Currently I'm working at Casco, which is a London-based fintech startup, and we're building an awesome insurance platform. Also, I'm working towards my bachelor's degree in University of Latvia, and I got recently AWS certified. Apart from that, so if you want to give me some feedback during the talk, or the other way around, if you want to rant about my talk, so here's my Twitter handle. Feel free to use it. So let's begin. So why HTTP caching? I have a question for you. How many of you have heard something about HTTP caching? All right, it's quite good. And what have you heard about it? You raised the hand, so what have you heard about HTTP caching?
I think quite a lot, and I deal with different issues. Someone just asked me a question, maybe I'll...
Well, okay, can you name some benefits of doing or not doing
Yes,
it?
of course, we're offloading servers, especially high-loaded systems. If we can put some, for example, a page in cache, then servers can very fast give it to a client. And we're offloading the system, and especially...
Okay, you know. All right. You can grab a beer, probably. So, well, I hope that everybody already knows a lot about this stuff. But if no, well, at least I'll try to get you interested. So, yeah, these are the benefits. I think the caching should be used. These are the benefits, what you can get out from it. So, first of all, you can sort of decrease latencies. That's what already was mentioned here. You can decrease response times from your servers. Given that, you can also decrease costs of running your servers, and you can decrease costs of data transfer out from your data center. And actually, you can also decrease costs of your end users if, for example, they have a monthly subscription on their mobile and they cannot afford to transfer a lot of data. And I bet there are a couple of more reasons that I haven't listed. So before we go into caching, let's first of all look at how HTTP works, just in case somebody does not know. As you know, there's like client and the web server. I'll call web server origin sometimes. That's just for your information. Then there's a communication between them, which is done by exchanging request and response pair. And in that request and response, there are HTTP headers, which are kind of crucial when we're talking about HTTP caching. Also, I would like you to look at this example. So I'll be using some of these in the presentation. This is basically a curl command to request some page, and as you can see, it lists the request headers with the arrow pointing right, and it lists response headers with the arrow pointing left. So that's just so you understand what we're talking about here. Right, so what are HTTP headers? Let me explain. I'll try to. So basically, they are components of HTTP message. That's one thing. Another thing is that they define the operational parameters of the transaction, of HTTP transaction. In other words, they kind of tell web server and the client, like your browser, or some, I don't know, proxies in between, how to deal with this request, what to do with it, whether it should be cached, what is the type of your content, and many other things. And I would divide them into two groups. There are like headers defined by RFC, which are kind of standard. And then there are like custom headers, but they tend to overlap slightly because they're like some headers that are commonly used, although they are custom ones. Right, so here's a list of some request and response headers. It's probably not a full list, but it at least gives you some idea of how many there are. And these are, I guess, the most popular ones. And today I'll be touching some of these, the underlying ones. So it's just a small fraction of all the headers. So, but before I start talking about the headers and all that stuff, let me show you some diagrams that hopefully will outline how HTTP caching should work, or at least works. So, here's an example of very simple caching scheme, I would say, where caching is only implemented on the client side, so it means only the browser is actually caching something. There's nothing in between. Right, so it is already better to have something like this. You can only achieve this by using the headers that I'm going to be talking about later. But the idea here is, so please note that there's like a timeline on the bottom. So it means that, for instance, if client 1 makes a request to your web server, the web server adds the caching headers and then responds to client 1. It means that the next time the client 1 makes the same request for the same object and it's cached locally, it will be just taken from the local browser cache, which already means that you have decreased the latency. There's no need to do that round trip to your origin, which is probably time consuming. But let's add a caching proxy layer in this image. So it's roughly the same stuff, right? But you can see that green thing that says caching proxies. It's not a typo, but caching proxies actually do mean that there could be many like proxy layers, one on top of other. For instance, you can implement caching proxy in front of your origin, then there might be some other things like CDN, and then some organizations might implement caching proxies in their businesses, and so on until it gets to the client. And so the benefit of doing this actually is that, so you can see that in this image, only the first request from first client actually hits the origin. And then the subsequent requests from other users hit the caching proxy, probably the first or the second, and then it kind of repeats. It kind of goes on like that. And yeah, the obvious benefit here is that you get less hits on your origin, which means that you need less servers probably. So here's a short recap of all the good things that we already kind of noticed in these schemes. So less requests over wire is if content is available locally, speeds things up. First thing you load the page, it maybe takes a second or two. Next time you refresh it, it's already there. It basically loads instantly. It means that there are less origin hits, which in turn means that content is served by cache, and there's no need to generate the content. So you don't need to spend time generating it. You don't need to spend resources generating the content. This becomes important if you're dealing with huge traffics. And finally, I mentioned the CDN thing. So the content can be distributed globally using CDN, which means basically that your proxies, I'll call them edge locations sometimes, they can be put closer to your end users geographically. So if if you're using a CDN, there's probably a CDN server in Riga and CDN server in some other cities, and your origin servers might actually be running somewhere in Amazon cloud, which is located in, let's say, Frankfurt, right? So, moving on, here are some numbers. Basically, they illustrate the correlation between cache times and hit radio and requests that are going through to origin. Well, they don't kind of really show anything meaningful, but I just wanted to put some numbers in. Yeah, but at the same time, they give some kind of an impression. Well, I mean, you can see that the amount of requests going to origin as you increase your cache times decreases. Right, but so far I've talked about caching and all those layers with the assumption that the content will be cached for some set amount of time, and when cache expires it will simply be regenerated by the origin. That works very well for static assets, stuff like JavaScript, CSS, images, whatever, things that don't change frequently. But when you start dealing with more dynamic content, it becomes a bit more trickier because you have to kind of invalidate caches, you have to check it, and so conditional requests come into play. They're very useful. So all in all, conditional requests is a way to kind of check if content has been modified since you last requested, or or in other words, you can kind of use it to invalidate your cache. All right. And here's a diagram. Hold on. Right. Yeah. So here's a diagram. So you can see that there's a difference is that now all the arrows actually go through to origin, which is kind of contradicts what I was saying before. But please note that there's the server is returning different status codes. So the first request comes in, it returns 200. The second one comes in and it returns 304. Do you guys know what 304 and 200 is? Yeah. All of you, can you raise your hands? Okay, I'll explain. So 200 means 200. Okay, it's like the classical response status in the HTTP protocol. 304 in turn means that, well, it's actually called 304 not modified, and it means that the content you are requesting has not been modified. So I'm not going to send you any content in the body. So there is no body on 304. And I will give you an example, a code example, and some curl example. But the idea here is that, so actually let's just go through examples. Right, so this is a very simple and I hope not too hard to read PHP script. So let me explain briefly what's in there for those who don't understand. So important part is let's say the third line, which is timestamp value, which here is kind of hard-coded, but in normal circumstances it would come from database or memory cache, like memcache or Redis or whatever. But here it's hard-coded, just for illustration. So the next thing that happens is we convert that timestamp into a specific like a time format in GMT and the GM date. And then finally, well, not finally, then we add a last modified header. So I'll give it an example in next 2 slides, but just try to memorize the thing and at least try to understand what's going on here. So we're adding the header, and then there's an if statement. that says that if there's a if modified since header present in the request, and the value of that header is greater or equal than the current timestamp, which should be coming from database, then simply return 304 not modified and exit. Do nothing, right? Because nothing has changed. And then after that, if that if statement does not evaluate to true, it will get to sleep file, which just mimics doing something very hard. So, so here's another example of curl request, right? Again, in this request, I kind of mimic the execution of the script, and you can see that we're not sending almost any request headers, only the host, and then the response is HTTP 200, and it also has the last modified header added, which was like added by the script. And well, there are three things that are important here, and those all are underlined. Last one is the time it took to actually do the request, and it's 5 seconds, which is like a lot because it had to do that hard work thing. So the next request, this is what your browser actually does behind the scenes. You don't have to do it like manually, or your application does not have to do it. So the next request, on the next request, your browser would include the if modified since request header. And the value actually comes from the previous response. You see the underlined last modified? It is exactly the same as the thing we are sending. And this time the if statement evaluated to true, so we got 304 not modified, which is probably a response just a couple of bytes, I would say, because there's no body. And importantly, the time it took to execute is just like milliseconds. Obviously, there's not much going on in that script, but it kind of proves the thing. Right, so, but, as you know, there are only two hard things in computer science, right? One thing is cache invalidation, and the other thing is naming things, right? And this is the case of one of those things, right? So I'll try to outline an example problem situation. It might be very trivial and it might look like dumb because you can probably fix it in a couple of minutes, but this is just an example to illustrate why this is well, maybe not important, but why should we look at this, right? So let's assume that there's a blog post stored in database table. Okay, imagine that, right? There are some tags associated to that blog post, which are actually stored in a different database table. And let's also assume that adding or modifying the tags associated to the blog post does not update the last modified time of the blog post itself. Hope you're still with me on this. So the problem with this is quite obvious. So if last modification time of the blog post has not changed, it means that it hasn't really changed. It appears that it hasn't changed, but actually it has, because you modified some related resources like tags. But there's a solution for this. So instead of using last modified header for content revalidation, you can actually use entity tags, which is long for e tag. The header is actually called e tag. Yeah, and the most important thing and the biggest difference between last modified and e tag is that last modified is a date value in that header, but e tag is actually hash value. And given that it's a hash value, it can be constructed from several variables, which is like the most important thing here. So again, similar code example. The obvious differences here are on the top, that now we have, let's say, two last modified times. One is, let's say, last modified time of the blog post itself. The other one is the last modified time of the resources, or I don't know, the linking resources, database entry, or whatever. It's just another variable that comes in. So after that, we actually take those two variables and we MD5 them, and we assign it to the etag variable. Then, same as before, this time we're sending etag. Last time we were sending last modified. We send that MD5 hash value in the header, in the response header. Then again, there's a similar if statement, which evaluates true if the etags match. In case the if non-match header is present in the request. And then finally, again, it does something very hard. So, yeah, the key thing here is that I wanted to illustrate is that in this case you can like use 2 variables, 3 variables, as much as you want variables to actually construct the MD5. And if one of those things or parts or variables changes, then the whole MD5 changes, which basically invalidates your cache. Well, again, if worst comes worst, and I've seen the cases like this where we had a case where we couldn't really set or decide the variables, or I don't know, fetching the variables would not really make sense. So we decided to simply MD5 the response body. So we build up an HTML or whatever, and then we MD5 that kind of string, and then we send it as an etag header. So you might think, well, that kind of doesn't make any sense, right? Because you're just the whole purpose was to reduce time, but actually you're just spending the same amount of time. But it's not true, because if you can send 3 or 4 even after you have generated the whole thing and time has passed, the response would not have the body, which means that data transferred over the wire is less. It's just few bytes, just that 3 or 4 not modified response, which could be important for things like, well, for people on mobile devices, because although they have to wait the same amount of time for first byte, they don't have to download all your huge HTML pages or whatever, because they're the same, they haven't changed. Right, so pretty much the same example, except that this time, again, this is like first request using no request headers. Etag comes back as a response header. On the subsequent request, we send the same value if non-match, and that script will send back 3 or 4. I'll recap that. Browsers do these things. They do send these if non-match and other headers on subsequent requests if they were present on the previous request. Again, recap of benefits. So, revalidation could be less expensive. I didn't really show that, but well, the idea is that if you have to generate a response, the whole body, it takes some certain amount of time. But on the other hand, you could use some, I don't know, memcache or other things in a smart way to actually speed some things up, so that you don't have to generate that response. So you can quickly just check things. If they're still the same and haven't changed, just do 3 or 4 and you forget about it. So the next thing was that amount of data transfer decreases, which kind of saves you some bucks or your clients. And there's another interesting thing. So you can also use a thing called stale while revalidate on a caching proxy level, if it supports that, of course. And stale while revalidate is a feature where basically your caching proxy serves stale objects while it revalidates basically while it goes to the origin to get a new one, and it does it asynchronously. So if you're making your request, you get a response immediately, and at the same time server in the background is just going to origin, fetching it, and kind of updating the cache. So that's it. So there's another thing I want to briefly touch. So you might think, well, what tool should I use for this caching proxy layer? And there are actually various tools and services. I haven't listed all of them. It's probably not possible. I've listed the ones I've heard about or I've used. So the first one is Apache Traffic Server. It's also sometimes referred to as just ATS. I have used this thing. It's quite, I would say it's quite good. It tolerates all the request headers. It's quite robust. It's full of features. So yeah, it's a good one. It would be my choice #1. The next one, actually the next two are Varnish and Squid. Varnish is kind of popular. I bet you have heard about it. Squid is, I guess, less popular. I haven't used any of these two, so it's hard for me to make any comments. Yes, I have Nginx, which is actually like striked out on this list, because yes, you can use Nginx, but I would really not to suggest. I would not suggest doing that. And the main reason is that Nginx is not a caching proxy, if you will. Yes, it can do caching, but when you set it up as a caching proxy, you kind of set the cache keys in your configuration, and those cache keys cannot tolerate all the headers that we will be looking at, things like cache control and so on. So it's not a real cache proxy. At the end of the day, there's also actually another thing. So in Nginx, when you set it up to cache things, you actually have to specify for how long the cache is valid, or after how long it has to expire. And there are headers that actually should control those amounts of time and values, and Nginx will simply ignore that. So if you set it up to cache for 1 hour and your header says 10 minutes, it will cache for an hour. And that's something you don't want. And then there are services, like I've used Amazon CloudFront, which is CDN. I bet there are others. Yeah, the cool thing about these is that you don't have to kind of set them up. Of course, you have to pay for them, but the benefit is that they're distributed globally and their network is quite huge. And in ideal scenario, you actually use both. So you use CDN, which is a sort of a proxy, and you also use something in your organization on top of your origin. Right, so remember this thing, right? These were this is the slide where I listed some of the headers we'll be talking about here. So I kind of mentioned and explained some of them. I mentioned I mentioned if match, if modified since, if non-match. They're kind of in the same category, I would say. I mentioned last modified. I haven't mentioned vary, but I will. Then, well, age, it is kind of related to caching. Sometimes cache devices or those cache proxy servers or whatever include the age header, which indicates for how long this object has been in cache. So it says if the value of age is, let's say, 60, it means that this thing has been in cache for a minute. And it can give you a rough idea of how this thing is all, hence the age. Right, but in the next slides, I'm going to focus on the cache control, and those will be I would say 2 headers that you can use to control the cache for how long to store things, should they be stored, and so on. So cache control. So I guess if there were a default super header for caching, this would be it, right? Another thing is that it is a response header, hence the arrow pointing left. So it's a response header. And it usually looks something like that, as you see an example, which is like a list of directives, I would say. And those directives tell the cache devices what to do. When I say cache device, I actually mean anything, like any cache device. It doesn't really matter whether it's your proxy, whether it's CDN, or it's your browser, the client's browser. So they all should work the same. And then there are some directives like public or private, which basically tells whether this thing is, content is public or private. Public means, yeah, fine, cache it. Private usually means probably don't cache it because it's for one single user. Like if you're logged into some dashboard and you see the dashboard page, usually it's private because it's only for you. No cache means like that the content should be revalidated using those conditional requests, and it will basically not store it for some amount of time. No store, it just means don't store things. Usually used for some sensitive content, I would say. So max age is the one that you can use to actually tell for how long to store things. So if you set max age to, I don't know, 600, it means store this thing for 10 minutes in the cache. S max age kind of similar. There are many more. You can just look them up. I won't go into very detail about every, but an interesting one is actually no transform that I want to touch briefly. So turns out that some mobile carriers or providers actually transform the responses before they get delivered to the end client. So if you're opening up a web page from your mobile, it goes to over the carrier to their, I don't know, data center or whatever they have there. Then it goes to the origin through all those caching proxies, whatever. And no transfer means that, well, hold on, I'll get back to it. And then when the request comes back and the carrier tries to send it over to you, it wants to kind of squeeze it as much as possible, because so the time is decreased and the number of bytes sent are decreased. So imagine you have an HTML page. The carrier might just strip out every comment from your HTML page or things like that, right? So no transform actually tells that don't fuck with this response, right? And it could be critical when you're, let's say you're serving some scientific data that has to be byte to byte precise, and it should never be changed. So sometimes comes in handy. I don't know how many of carriers actually do this, but that's what it says in the spec. So another one you can use for controlling cache is the expires header, and this is sort of a old schoolish header. So if you have, let's say if you have both cache control and expires, cache control overrides expires. The reasons, I guess, why I don't like this thing is because you cannot control much with it. It doesn't give you that room. The only thing you can do is just tell, well, this thing expires in, no, not even in. This thing expires then. That's it. Yeah, so it's kind of, it works, but I mean, it's not cool. And another thing, yeah, it has to be in this specific format, which you have to like create. I don't like it. So, okay, let's move on. So I told that I will talk about the very header. So this is sort of an important one, I would say. So yeah, basically, this is fun actually. So as it says with like huge letters here, try to read this thing. The very header lets the caches know which request header values to use for cache key. So yeah. So what I'm trying to say is actually that this header is really extremely powerful. and by using it the wrong way, you can fuck things up. By not using it, you can fuck things up. By using or including too much things in it, you can also fuck things up. So please listen in. I'll try to kind of give an explanation of how it should be used and why. So again, vary is a response header, hence the arrow. Here's a small example of how it usually looks. And the key thing that you have to kind of see here is that the vary header's value is actually other header names, right? So it's not something random, it's header names. And those header names come from the request. So you can see I have these two clients, well, sort of client request responses. The first one on the left is a client that, let's say, accepts gzip. Do you know what gzip is? Okay, maybe I'll explain. So gzip is basically a compression, right? And it is good because when you send a request, you can tell that, hey, I support gzip. And then the server can understand that you support gzip. You can compress your response, send it back compressed, and then your browser will decompress it and display it for you. Which means that the data transferred over the wire, again, the bytes are, the number of bytes decreases, which is good. But the thing is that not all browsers actually do support that. And this might be a problem when you start caching. So, yeah, I'll try to explain. So I said that in the previous slide, header values to use for cache key, right? And if you imagine that your cache is actually just a key value store, right? So the vary header would tell the key value, the header value would tell that key value store from what to construct the cache key, right? And maybe the example will help. So again, I have two clients, one that is capable of doing gzip, the other one is not. So the first client would send a request that would go through some caching proxy layer. In that request it tells, hey, I support gzip, see it's underlined, and also sends some other header like user agent, whatever. So the server understands that the client can read gzip, zips it up, and sends it back. But on the way back, it actually gets stored in the caching proxy, right? In the cache layer. So what if next client comes in and asks the same exact thing, but with one difference? He does not have that except encoding gzip thing in the request, which means that, dude, I don't understand gzip, so don't give me it, or at least, well, in other words, I don't know what gzip is. So the problem with this is that, according to the schemes, the previous schemes, the second client's request would go to the caching proxy. The caching proxy kind of understands, well, if he's asking for the same thing, okay, I'll just give it back to him. But actually, he would give back the gzip content that the second one is not able to understand. And for this client, it would not be an HTML or JSON thing, it would be just some gibberish, because it's gzip, right? So this is why the vary header is so important and powerful. This is just like a trivial example, but the idea is that, well, it kind of constructs the cache key. So in the first case, the cache key would be gzip curl, hence the vary header. And in the second case, it would be just curl, which means that in cache, they are actually stored as two different values, right? And if the second one comes in, there's no gzip, so the cache key should be different, and it would go through origin and return the response not gzip. Right, so yeah, this can be used for many other things, like I don't know, you name it. We have used this for like cache. Well, I mean, browsers also tend to send. Well, they do send refer header, so you can include refer headers. So I don't know. Let's say. Well, okay, let's not go in there. We can talk about it later. All right, guys. So that's almost it. And I'm almost running out of time. So, but before I end, I actually have some, well, a few suggestions I would like to give you related to this caching thing. So, thing number one, let your application add caching headers and handle caching headers instead of your web server. And, well, I've seen people actually doing this in web servers, like they add a configuration in Nginx, just send these headers to every response. That's actually shit, because I think that this, well, first of all, it's shit because then you have a coupling between your web server and your application, which is lame. The second thing is that you cannot really control the, well, you can, but it makes it really difficult. Sometimes you might want to have different cache expiration times or those directives depending on the page you're like serving, right? So let's say you run a news site, bbc.com, whatever. The first page most likely changes quite frequently because they're adding new stuff like every couple of minutes. But the other pages, the specific news pages, they probably don't change that often. So that means that your home page, you probably want a really small cache time, like, I don't know, 5 minutes or 10 minutes or whatever. And on those more deeper pages, like news pages, you can afford bigger cache times, like 1 hour, right? So moving things into application layer actually allows you to do that quite easily. So the next thing, which kind of ties in, is you have to be smart about the way, or about what you cache and for how long. Kind of goes into the same example. Sometimes, well, if I would do this like the proper way, I would probably delegate the setting of cache expiration times to I don't know, editors instead of developers. Developers will hard code it, but yeah, all I'm saying is that this sometimes might be a business decision, right? For how long things should be cached. Because, well, one thing is, yeah, you can cache things, but there might be cases where you have to take down the page because of legal reasons, and then it's in fucking caches, right? So be smart about that. Also, goes back to that one of the hardest things in computer science. Think well about how you will invalidate cache, because I know it kind of sounds trivial at the beginning, but I've seen it goes terribly wrong, and trust me on this. And the final thing that I have actually is a kind of notice. Keep in mind that errors also can be cached. And it could be good and it could be bad at the same time. For instance, your web page is getting a huge amount of traffic, and I don't know, database is not able to handle it, and it suddenly pops out of 500, which is like an internal error or something like that, and that 500 gets cached. And it could be good because the next request will also get 500. If that 500 is like cached for a small amount of time, like 1-2 minutes, then it's probably fine, but I guess it depends on the case. And the good thing is that it kind of gives space or time for your backend service to actually recover, while it's kind of serving the 500, thus not hitting the origin every fucking time. And in a bad way, it can also be your web server generates 500 for some reason, and it gets cached for, I don't know, 1 hour or 1 day, and suddenly it's your homepage, or I don't know, some important API endpoint, doesn't really matter, so it kind of gets tricky. So just keep that in mind, bear in mind. Alright, so now this is really almost it, and so any questions? I'm happy to answer any question. Hope you at least understood what I was talking about. Go on.
I have one about those e-tags. The question is, what kind of browsers does not support those e-tags, and maybe there are some workarounds or something. Maybe you can name it.
Well, I know that all modern browsers do support e-tags.
Of course. Because the question was, does not.
Yeah, I know. I don't really care about the ones that don't. Probably IE has problems with it, like older versions. Yeah, the most tricky one is actually the varied one. I know IE definitely has problems with it. I know even Chrome recently had problems with it. So, but I think they fixed it. So, yeah, I don't know. I have never actually looked into that. Who doesn't support it? To be fair, I think most of them should support it because this thing has been around like for 25 years.
But mobile devices?
They're still web browsers. You probably use WebKit or whatever, right? I don't know. But I mean, you should still use them because most of the browsers still do support them, right? Even if some don't, fuck it, who cares? Just like 1% maybe. Any other?
You solve this problem with validation caching your project. And when you start solve this problem, in which phase of project?
So, back in the days, well, yeah, we kind of did solve the problem. We initially started with last modified, which turned out is shit. So then we tried to use e-tags with some variables, which didn't really work. At the end of the day, we just MD5 did the response body, the whole thing, and that kind of solved the problem. As long as your body does not change on every request, that was also a tricky thing. We had something in the response that just puts in timestamp into every response. So every response is fucking different, right? And every e-tag is different, so we had to fix that. But yeah, we did solve the problem. And well, yeah, the reason why we did this caching stuff was because we were running quite a huge site with lots of traffic, and simply spending money like this on huge origin boxes was just insane. So caching is really, really not expensive thing to implement. Did I answer? Cool. Anybody else?
What about keeping database updates in a separate store so you can cache the main database and roll the updates after some time, after some period of time?
I'm not sure I follow the question.
Well, there is a design approach to keep the database updates separately.
All right.
And is there any possibility to cache that kind of approach? To use caching together?
I bet there is. I don't know much about it, to be fair, but I know that those entity tags could be used in a way, I guess. Well, first of all, let's say when you update something, you usually send a post or put request instead of get, right? Those don't get cached. But I don't know. Maybe some caching proxies support a feature where when you kind of send the post, it can kind of invalidate the cache. I really don't know. So, sorry. Jans had a question.
Yeah, so maybe you can name if there is some kind of a library or tool that can help when you want to actually start using HTTP characters.
Well, I can talk only about the languages I know, which is mainly like PHP. And PHP, well, I think most major frameworks do support that, like, I don't know, Symfony what's called request response things, they can do it. You can just like
There's a special bundle, it's the cache bundle.
yeah, exactly. So you just call I don't know, set public or make public on the response and it's done. So you basically can implement some middleware or something like that. You shouldn't ever do it in this way as it was shown in the example. It's crap. Go on.
Just wondering if HTTP caching is kind of a final tuning, because there is no point. Your server can barely handle hundreds of simultaneous requests.
Well, true, but I mean, you can decrease the amount of traffic going to your server, right? So that's kind of, it tends to not work when we're dealing with things like APIs and dynamic content, but it does work when you're dealing with websites. And it does work very well because the content doesn't change that often, so it just works, right?
One comment, some time ago I read an article, there was a company, quite big gaming company. They had like a website, user accounts were, and once users started to log in there to their user accounts and saw that I've logged in, for example, as Stanislav.
Yeah,
and I see that user is Maxim, for example.
Yeah, so the private content got cached.
Yeah, and they just thought like, oh, fuck, we were hacked or something like this, and yeah, finally they found out that someone put caching on web server level, yeah, and private content was cached, so you should be really, really careful dealing with logged in users.
Yeah, it does sound like trivial, right? But it is not. When you start actually implementing this, you will like end up with probably hundreds of bugs because of this. So, yeah, what we do is we try to like test all things carefully. So, all right. So I think it's time to end, right? No more questions. If you have any questions, approach me afterwards. Thanks for having me here, and don't forget to leave feedback.